Okay, next question. So we have a velocity time graph. This is a kinematics question, guys, obviously. So when you're dealing with a kinematics question, just be careful. It's not always a velocity time graph. Sometimes they give you acceleration or a displacement time graph. So just be careful. This is a velocity time graph. So the y-axis is velocity, the x-axis is time. So if you go to a point like here, this is time, let's say 5 minutes. Velocity is -8. Okay, that's the first thing. Part A. Find the smallest value of t for which the particle is at rest. Now, when is this particle at rest? Well, at rest means it's not moving. If it's not moving, what's its velocity? 0. So it's basically finding where its velocity is 0. And it says find the smallest value. So that's going to be, well, there's two places where its velocity is 0, here and here. Its smallest one will be here. And it says find the value of t. So we're going to find, well, obviously the value of t. You could write this equals 0 and then solve it using nsolve or whatever. But I like, in a paper 2, guys, these types of questions, I like to draw the graph because this will help you, it'll help you solve the other questions as well. And if you can actually get this graph on here, then, well, you can trace and find all the different points that you need. Now, just remember, guys, for a graph, you have to write x, not t. So it's x sine of x minus 3. Make sure you write it in properly, guys. Sine you can find in this place here as well. And it looks like this. Just make sure, obviously, guys, that it looks like this graph. It should look the very same. Now, obviously, the scale is a bit different, so you can see the negative values and a bit more over here, but generally it's the same. It goes up here, down, up, down, up, down, up, down. Fine. What value am I looking for? I'm looking for this value here. So there's two ways to do it. You can find you go to menu, analyze graph, you can find a 0, or I like to sometimes just trace. If this works, you can use it because it gets the different points. So there you go. This is a 0 there. Don't worry about this, guys. It's just your calculator unable to get all the way to 0, but that's basically 0. That's a tiny number. So the answer is 6.7442. You can, if you want, guys, to show working, you could say part A is here. Let me do that again. Part A is here, and then you just kind of that's your working there, and the answer is 6.7442. T equals 6.7442, or 6.74. Part B, find the total distance traveled by the particle. Okay, well, the total distance, the distance, guys, is given by the integral. Now the total distance, it goes from 0 to 10. So the particle is traveling for 10 seconds. So the limits are 0 to 10. Now for distance, remember, if you integrate from 0 to this point here, you're going to get a negative answer because it gives you this area. And then if you integrate from here to here, you get a positive answer because it gives you this area. And then if you integrate from here to here, it'll give you a negative answer. So you need to get the negative, the positive, and the negative, and add them all up. So the positive version of this plus the positive version of this. But there's a much easier way to do it. You can just put in the absolute value sign. So it's just the absolute value of t sine t minus 3 dt. That's in the formula booklet. It's the integral of mod, or the absolute value of v of t. And this I can just put straight into my calculator. So I'm going to do the integral of, you can find the integral, guys, here, and you can also find the mod here. It's there. So the integral is this, from 0 to 10. The mod is this, we're in radians. We want to be in radians. I can use t here, guys, if you want. T times sine of t minus 3 dt. Press enter. 37.0969. 37.0969, which is approximately equal to 37.1. What are we dealing with? I'm guessing it's meters, is it? So 37.1 meters. Okay, part C. Find the acceleration of the particle when t equals 0, right? So if this is the velocity, how do I get acceleration? Well, I differentiate. If you remember, guys, I use SVA, displacement, velocity, acceleration. And this way you differentiate, this way you integrate. So we're going to differentiate velocity. So I'm going to get V dash of 7, because it's when time is 7. Now you could, guys, differentiate this and sub in 7, but remember, it's paper 2. You have a calculator. It's far easier to just literally go. Well, I can go to here and use the derivative. So dd, well, again, I can use t. ddt of t times sine t minus 3. Sorry, guys, I've clicked the wrong thing. I need the derivative at a point, and actually I don't see it here. I thought it was there. Anyway, it's not there. I can just find it here. Menu, calculus, hang on. Menu, calculus, numerical derivative at a point here. The variable is x. I can call it t if I want. The value is 7. It's at 7. And the first derivative, by the way, guys, you can get the second derivative, but I just want the first derivative. So it's ddt of t times sine t minus 3 when t equals 7. Fine. Press enter, and I get 5.9343. 5.9343, which is approximately equal to 5.93, and that'll be meters per second squared if you want. Meters per second squared, because it's acceleration. And guys, it's worth looking at your graph. Does this make sense that the derivative at 7, so 7's about here, is 5.93? Well, yeah, it's positive and it's pretty steep, so it makes sense. Okay, that's that question, guys. I'll see you for the next one.